Hello again, Year 9. Today we are going to be carrying on looking at equations, and we are going to be looking at a new technique for solving a two-step equation. This technique is still going to involve using inverses, but we are going to write out the equation using a function machine. So before we get started, we're just going to begin with 10 quick questions. I would suggest you write numbers 1 to 10 in the back of your book, and then just jot down what you think the answer to each equation is. There's no need to write the equation out, just what you think the answer is. So pause the video here, because I'm about to do the answers. So the answer to number 1 is x equals 4, because 4 plus 8 equals 12, or you could say 12 take away 8 leaves 4. Answer to number 2 is 9, because 9 take away 2 is 7, or you could say the inverse of take away 2 is add 2, 7 add 2 is 9. Number 3, 2x is 20, x has to be 10, because 2 times 10 is 20. For number 4, x is 12. For number 5, 8 times x being 24, x has to be 3, 8, 16, 24. Number 6, x is 11. For number 7, something divided by 2 is 6, so timesing by 2, the answer must be 12. Number 8, x equals 15. For number 9, x equals 45. And finally, we got it, x equals 21. So the objective for today is be able to solve two-step equations using inverse function machines. If you've managed to print out the note sheet, that is great. If not, make sure your title and objective is clearly written in your book along with today's date. We can extend our ideas of using inverses to harder equations by using function machines. It might be useful to have a couple of different colours for the questions that we are going to try and do today. So this is just a different approach to solving equations. So I have the equation 2a plus 7 equals 15. And what I'm going to think about is in this algebra of 2a plus 7, what is happening? What does 2a plus 7 actually mean? Well, it means that I am starting with a, and the 2a means that I am multiplying or timesing by 2. And the plus 7 then means I am adding 7. And what comes out of my machine, what is this equal to? It is equal to the answer of 15. I can now use this function machine that I've written to write some inverses. I'm going to write my inverses in a different colour. So, working backwards, and the order is super important, if I go in the reverse order of this function machine, I need to do the inverse of add 7, which is take away 7. I need to do the inverse of multiply by 2, which is divide by 2. And now I can use this purple inverse machine to work out what a must be. I start with my 15. I subtract 7. 15 take away 7 is 8. And then I divide by 2. And 8 divided by 2 is 4. So I know the answer to this equation must be a equals 4. I can even check by substituting the number in. 2 4s is 8, and 8 plus 7 does equal 15. Let's look at some more examples. What does this algebra mean? Well, it's 3b take away 2. So that is telling me I'm starting with b, and it's 3b, so I am timesing it by 3, and then I am subtracting 2. And the answer that comes out is 16. Let's think about the inverses. What is the inverse of subtract 2? That is add 2. What is the inverse of multiply by 3? It is divide by 3. So let's follow through this from the number 16 and see what b has to be. 16 add 2 is 18. And 18 divided by 3, count up in threes if you need to, but 18 divided by 3 is 6. So I now know the answer to this equation is b equals 6. Now in my next example, the equation looks a little bit back to front. It says 33 equals 5c take away 7. But if 33 equals 5c take away 7, you could still think of this as 5c take away 7 equals 33. Doesn't matter that the answer is on the right hand side or whether it's on the left hand side of the algebra. So let's think about what the algebra means in this equation. 5c take away 7. Well, I'm starting with c and I am timesing it by 5 because I have 5c. And then I am subtracting 7. What is the inverse of this? Well, the inverse of subtract 7 is add 7. And the inverse of times by 5 is divide by 5. So our answer was 33. Let's work this one backwards using our inverses. So 33 add 7 is 40 divided by 5. 40 divided by 5, well, there are 8 5s in 40. So this tells us that c must equal 8. (3n plus 8 equals 35. Just reading it the other way. So I'm starting with n. I am timesing by 3. I am adding 8. And the answer is 35. What are my inverses? Well, the inverse of add 8 is take away 8. The opposite of times by 3 is divide by 3. So let's follow this through with our 35. 35 take away 8 is 27. 27 divided by 3 is 9. So our answer to this one is n equals 9. Final example. I have 10n take away 12. So n is being multiplied by 10. And then 12 is being subtracted. And the answer is 28. Inverse of take away 12 is add 12. The inverse of times by 10 is divide by 10. So let's see what happens. 28 add 12 is 40, and 40 divided by 10 is 4. So n equals 4. Now there might be one or two of you today that think I do not need to show this working out, and you would be wrong. If I just see an equation and an answer, that is not good enough. I am expecting to see your explanation. If we are going to progress on to better ways of working with equations, I need to see you understand these concepts. So write me out the function machine, write me out the inverse machine, and your answer. So go back to my instruction sheet. There are questions on the PowerPoint which you'll be able to access. Remember, there are answers, so I'm expecting you to mark your work in the last 5 minutes, and then this would be a great photo to share with me in the assignment section. As always, if you're having any problems, you may ask in the Ask the Teacher channel.